Okay. Then next topic in the chapter motion, graphical representation of motion. Previously we derived uh, three equations for motion: v equal to u plus at, s equal to ut plus half at square, and v square minus u square equal to 2as, and also um, solved some numerical problems So let us describe the motion of a body by using graphs, by drawing a graphs. So let us um, draw or describe the distance, time, describe motion with graphs. We have totally two types of graphs. One is distance time graph and other one speed time. Sometimes here we consider velocity time. Speed time graph or velocity or velocity time graph. Velocity time graph. This is also known displacement and time graph. Distance time graph, displacement time graph, speed time graph, velocity time graph. While drawing the graphs, let us consider both distance and displacement are equal. Both distance and displacement are equal. So let us discuss the first one, distance time graph. Distance time graph. Distance time graph. Let us understand the motion of a body. Let us understand the motion of a body with respect to speed, time, distance, and displacement. We know if a body is in a uniform motion, it covers equal distances. It covers equal distances in equal intervals of time. Equal intervals of time. So, if we draw a graph for that uniform motion of a body, so we can calculate the speed or the velocity. So, let us draw the graph. On x-axis and y-axis. On x-axis we have taken time. Here we have taken either displacement or distance. Either displacement or distance. We know that for a uniform motion, the distance time graph is always straight line. So this is called as the slope. The slope of the slope the slope of distance time graph. The slope of distance time graph gives speed or velocity. Speed or velocity of the body. The slope of a distance time graph always gives us speed or the velocity of the body. Let us know let us calculate the distance and calculate the speed or velocity, assuming that here O is the initial position At any point, we have to identify a point A on the slope. Now, draw a perpendicular to time x-axis, to a time axis or on the x-axis, on x-axis. Then draw one more, mm, draw one parallel to the point A. One line perpendicularly to the y-axis, one line is parallel to the x-axis, the time axis. So this indicates the time and this indicates the distance time graph. So here consider OB. Here consider the OB. As we know, as we know, speed is equal to distance. Speed is equal to distance by time. See here, when we draw a graph for uniform motion of a body, always we get the straight line. Let assuming any point like A on the slope or a straight line, from that line, from that point, we have to draw one perpendicular to the x-axis and one perpendicular to the y-axis. So this line is parallel to the x-axis, that means represents time. This line represents the distance covered by the body. We know the formula for speed is equal to distance by time. Distance by time, that is equal to here. The distance is OA. The distance is OA. So OA by the time is OB. The time is OB. So speed is equal to OA by OB or AB by B. Sorry. AB kada. Sorry for that. Extremely sorry. AB. AB by OB. Here AB represent the distance covered because of these two are same. And OB represents the time because these are the time. So AB by OB. AB by OB represent the speed. So but AB by OB is known as the slope or the gradient. AB by OB is the slope or the gradient of the graph line OA. Therefore, in a distance time graph of uniform speed, the speed of the body given by the slope of the graph. So, this slope of the graph gives us here AB by OB is the slope of the distance time graph. Distance time graph, the slope gives about speed or velocity of the body. So the slope of distance time graph indicates the speed. Indicates the speed. So we can use a distance time graph of a body to find the speed of the body, to find the speed of the body. So the slope here AB by OB is a slope of distance distance time graph. Distance time graph. Distance time graph nothing but explain about the speed about the speed of the body. Distance time graph explains about, that means the slope. The slope is nothing but AB by OB. AB by OB. So this slope explains about the speed of the body. So what happens if the body has non-uniform motion, moving with non-uniform motion? If we draw graph, if we draw graph, this is for This is for uniform motion. Uniform motion. Uniform motion. Then for non-uniform motion, in case the body is moving with the body is non-uniform motion. In case of non-uniform motion, non-uniform motion, so let us draw the graph. Let's draw the graph. As usually, an x-axis time and y-axis distance. Y-axis distance. So we get a curved line. We get a curved line. So that curved line denotes. So here taken A. Here taken as A. OB, for example, taken as B and taken as C, it is a O. So here the curved line gives the slope, the slope of distance time graph for non-uniform motion, for non-uniform motion of a body, a parabola, like a parabola. Parabola. In case of uniform motion, it is a straight line. It is straight line. So in case of non-uniform motion, the slope is parabola. The slope is parabola. So finally, based on this graph, based on this graph, we can understand the motion of the body. When we draw a distance time graph, a graph between distance and time of a body, if you get a straight line, as a slope, then we can say that the body is in uniform motion. The body is in uniform motion. If we draw a graph between distance and time, if we get the curved line, then the body is in the non-uniform motion. Non-uniform motion. So in a distance time graph, if the graph between distance and time graph is a straight line, that motion is uniform motion. But in case distance time graph is parabola or the curved line denotes that the body is in the non-uniform motion. Non-uniform motion. In this way, we can describe the motion of the body by using distance and time graph. Distance and time graph. Okay.